Hi, this is Real World Audio, and quite possibly you are going to see the most important video on loudspeaker major breakthrough in this century, because many of us have been commenting on and noticed that there were incremental changes in loudspeaker technology over the last 60 years, but there was no major breakthrough happening. And I can report to you guys that yes, 2 years ago, there was a gigantic major breakthrough that happened. And I'm being extremely humble because I was the one who made this breakthrough. And those of you who have been watching my videos know about it, but just until now, maybe I have not really transmitted properly what sort of a giant landslide these voice of Lancelot speakers are. And now I'm going to elaborate on it a little bit, and I'm going to show you what they do and how I started doing that. And now I'm going to introduce the basics of how a voice of the theater A5 loudspeakers woofer is configured to work. And I'm going to show you what changes I did to affect a change in the sound so I get the missing deep bass. Because when we look at it, if you go, for example, what Jeff Day was doing to the Altec A5s, this was Leopold Stokowski's A5, the legendary conductor, who was conducting experiments with the first stereo setup 10 years before stereo was invented and the first recordings came out. And basically Jeff, they got those speakers and he tweaked them to the max, like with dual-owned stuff for the crossover, so it's like really pimped out. So what he did, and plus he built an extra external cabinet for them to look way nicer. But what you do not get from this picture is that these speakers are taller than a human being, and they are the size of a walk-in refrigerator, basically. And here the room is like extremely tall, so this is not an 8-foot tall ceiling, so this is not 2.5 meters. I think his room is something like maybe like 3 meters plus tall, like 12 feet or something like that. I don't know. I never been to his place. I'm just judging by this photo. So this is the path that people have been walking to push the envelope and to push the boundaries of loudspeaker technology. And as you know, crossover makes for a gigantic difference in sound. And by just using ultra high quality products and tweaking the crossover itself, you can make quantum leaps for the sound of these loudspeakers. And I'm bringing up these speakers because I would say that probably these are might be one of the finest executed examples of a properly up-to-date version of the Altec A5, and I suspect that these are, if they sound at least as good as my friend's Altec A5s, then quite possibly these might be quite likely the most natural, most lifelike sounding speakers you will ever hear. And however, for this the price to pay is like all of these dual-owned parts, which cost the price of a very expensive car, or your down payment for your house, or maybe like your entire house, depending on where you live, in which part of the world. However, even with these upgrades, the basic limitation stands. So basically you are getting an ultra high efficiency loudspeaker, but the low end response is limited to around 40 Hz or so. And what I did is that I found a way how to create this ultra efficient experience, how to make a handshake between ultra efficiency and bass extension, because so far no one has done it. People were just adding subs to their systems, but when you try to mate a sub to an ultra efficient system, uh, usual situation is catastrophe, and sometimes you can make it work, but like making it work and making it so that the sound is not completely dissociated but acceptable, it is still a far cry away from having ultra efficiency down for the entire spectrum. So when you are not using a sub to supplement what is missing, but you have the entire range reproduced by a single point source, guys, that's something nothing less than a revelation or a revolution in loudspeaker technology. And I can report that yes, it is possible. And how is it so? Let's have a look at the WinISD plot, a simulation of the output of this woofer, the Altec A515C, in a Voice of the Theater A5 cabinet. But now you have to note that this is not the actual output of the woofer. This is just the simulation, what the output would be if it would be a simple bass reflex cabinet without front horn loading and without the room effects as well. So basically, bass reflex cabinet with the free air size of the A5 cabinet and tuning frequency of the A5 cabinet, and the output would be this in an anechoic chamber. So I'm going to talk later about this program, WinISD. It's a free program. You can download it for free, toy with it for free. And if you are a loudspeaker designer, then this is an amazing tool. I would say it's a must for everyone. And here we go. So basically here we have a second order crossover. That's what people use for their Altec A5s. And as you see, it's crossed at 500 hertz second order. So basically it's really going strong until 400 hertz and then it starts dropping. But it's not a problem because the compression driver is going to take over from here. So this is just what the woofer is doing, and we are really interested about what's below 500 hertz. And it's going quite strongly, and you see around below 200 hertz it starts dropping a little bit. So there's like a 1 dB drop to 100 hertz. And then it starts to go up. So why is this drop happening? This drop happens below 200 hertz for virtually every woofer, and that's a natural thing because their coupling efficiency to the air starts dropping below 200 hertz. Even if it's a 16-inch or 18-inch driver, below 200 hertz, they just start dropping like a plane which has lost the engines and just going down. And now what's happening is that below 100 hertz it starts to take off again, and this is because of the port. So the port is tuned to 50 hertz, and that's going to bring up the output level from the cabinet. And this is what you are seeing here, this extra peak. This is the output of the port. So the driver itself, what you are hearing shooting at you, it's just falling down dramatically, but the port is filling out what is missing from the front production of the woofer. And as you see, we are getting a quite huge peak in the mid bass towards the lower end of the mid bass, and below 50 hertz it suddenly starts almost like a free fall down to nothing. And this is why when you have your Altec cabinets, there you go, this is why you have such an impressive mid bass from them, and then below 50 hertz it's like there is nothing, because there is a bump up at 50 hertz, so you are getting a couple dB in addition to what was before, like an octave above, like 50 hertz versus 100 hertz, beep, a bump there. And then below that, the downfall is even more steep because it's not falling from here, but your ear is adapting to that extra 2-3 dB peak that you have here and compares the deep bass against that peak. So the loss of the low end of the deep bass is even more exaggerated because of that extra boost in the mid bass you have. So what was I thinking? How to prevent this from happening, and can we do anything to extend the low frequency output? So can we gain, first my question was, can I gain the octave like down to 20 hertz or at least to 30 hertz? And yes, you can add that, and you can add even more. So first I was toying around with WinISD, and that's what gave me the idea to go against what every single person is saying online, that the 515 Altec woofers, they cannot put out any real bass, they can't even reach down to 20 hertz. And yes, by experimentation I found out that they are really happy working down to 12 hertz. Yes, you heard that, 1-2 hertz, which is way below 20 hertz, provided you give them the chance to work that way. So here you go. This is my voice of Lancelot loudspeaker, where I use the same driver as in the Altec A5, but instead of tuning it to 50 hertz, it is tuned to 18 hertz. So what happens here is that the energy where the port is working and where the bass output happens is shifted. And there's one rule in physics, that the total energy output of your loudspeaker driver is the same. And by tuning your port to a different frequency, you cannot add more bass. So if you tune the port lower, you are not adding more bass compared to tuning the port higher. What you are doing is that you are shifting the range where the port helps your loudspeaker's output. So what you see here is that up to about 200 hertz they have the exact same output, and below 200 hertz that's where the port starts to make the difference, because you see below 200 hertz the A5, which is shown by blue, it starts to produce more and more energy. So you start to see it in the output, and the highest energy is there at 50 hertz. And then after that it just starts plummeting like crazy. And now if I tune the port to 18 hertz, then what you see is that this massive peak in the mid bass is not there anymore. And the driver's output is falling. This is the natural weakening of the output from the driver. And that's because as we go lower in frequency, the woofer has lower and lower ability to produce the same sound pressure level from the same amount of energy. And we reach a point here which is just below 40 hertz where the two intersect. So above 40 hertz, between 40 and 200, this is where the A5 cabinet has higher output. And around the 50 hertz region, we have like a plus 6 dB difference in favor of the A5 cabinet for mid-bass output. And what we have here for my cabinet, what the solution I found is we have minus 6 dB in comparison. And actually this giant difference is what prevented people from trying it out real life, thinking that, geez, this really sucks, giving up 6 dB from the mid bass, this is not going to work. And I did not give up on that, because there's a lot more happening, and this is just the simulation of the cabinet without taking your room into consideration. So when you work with your room, you can make things work out. I'm going to show that in the next video. So right now, let's just focus on what's happening below 40 Hertz. So below 40 Hertz, the A5's output becomes non-existent. So when we reach 30 Hertz, we are like 20 dB down already. And when we reach 20 Hertz, we are like 30 dB down from the mid bass. And which virtually means that you are not getting any deep bass at all from the A5 cabinet. And here what we have with the voice of Lancelot is that we have like a gigantic additional output for the frequencies below 40 Hertz. So already at 30 Hertz we are like 1, 2, 3, 4, 5, 6, 7 dB plus over the A5 cabinet. And then when we are at 20 Hertz, this is like a 12 dB plus over the A5. So, and as we are going lower, this difference just keeps on getting bigger and bigger. And you would say that, okay, that's still commendable that we are getting like 12 dB plus at 20 Hertz, but is that sufficient to make a difference? And I say yes, it's sufficient, because I am using it in a real room. So if I were to use it in a concert hall, or if I were use it in an anechoic chamber, then yes, this output would not be sufficient to enjoy a 20 Hertz sound effect in your music material. But because it's happening in a real room, the real rooms have room effect to the sound. So it means that based on the size of the room, you get a certain frequency, which is called the Schroeder frequency. And below that frequency, you get a specific dB per octave boost for the bass. And now if you are an anechoic chamber, then the boost is 0 dB, and that's where you get this plummeting, very disappointing output. But if it's a room, which means it has boundaries, so the room, the sound is bouncing between your walls, then what happens is that if your room has a better room acoustics, it has a better acoustic seal, then the amount of dB per octave boost is getting higher and higher. So from the anechoic chamber 0, you are getting a 1, 2, 3 dB boost per octave for a poor sounding room. And if you have a recording studio, you can get up to plus 6 dB per octave for a perfect acoustic seal. So if you have a good room, then you can easily get plus 4, plus 5 dB per octave boost for the bass below the Schroeder frequency, which will be somewhere between 200 Hz and 100 Hz, depending on the size of your room. Or if you have a smaller concert hall, it will be between 100 Hz and 50 Hz. And if you have like a gigantic opera house, something like that, it will be below 50 Hz. And as you see, as the size gets bigger, the boost will be lower and lower. So you will not be able to use my idea for a movie theater application, which is the size of a real movie theater, because there the room boost is not enough to get your deep bass and subsonic bass to enjoyable quantity. However, what I did is that I redesigned the voice of the theater to work in a living room, and I redesigned it to use the benefits of the living room that it does to boost the bass for you. So instead of relying on a DSP to add boost and just massive excursion cones, and then you get back to the situation of using low efficiency drivers, I'm just keeping this ultra high efficient driver and as it weakens towards the bass, I am using the room to help me out in this situation to have high levels in the bass, and not just in the bass, not just in the deep bass, but also down to the subsonic area. And as you see, what we can do is we can tune our cabinet to have extra energy up here, or we can shift that energy boost to down below here. And this is what I have done, is that I have shifted the energy from mid bass down to deep bass and subsonic bass. And how does this work out? Did I lose too much mid bass? Did it become unenjoyable? How does it exactly work out? In the next episode, I'm going to show you exactly what the room does to the sound, what placing it in a rear room instead of an anechoic chamber does. I can tell you that it totally radically changes the situation. And we will see that what is the real world output that we can expect from an A5 cabinet and from the Voice of the Lancelot cabinet, because both of these cabinets employ front horn loading, which does not show yet here. And the Voice of the Lancelot also employs a transmission line effect, and also employs live cabinet, and also utilizes the floor boost, which is basically almost like a secret sauce. Some companies use that, and it effectively doubles the lung size of your cabinet for bass output. And that's what really allows me to enjoy deep bass and subsonic bass. So we will see how that works in the next episode. Thank you for tuning in. Bye bye.